All right, welcome to lesson number 9, the last lesson in unit number 1. And we're looking at the second part of angles in a circle. So last video we talked about how to cut a circle up into segments or find the angles and so on and so forth. Today I want you to be able to determine an indicated angle using properties of a circle. All right, so there are 3 properties I want you to be aware of. And the first one is called the bow tie. So the bow tie is this design here. So it's the bow tie that people would wear, gentlemen would wear in their necks more commonly in the old days, but it's the bow tie. And what it is, it's 2 triangles, okay, triangle 1 and triangle 2, and they're touching each other, okay, inside the circle, and all parts of the triangle, except for the middle of the corners, they touch the edge of the circle. So what happens here? Well, if I take the first circle, whoops, I'm going to take this first circle, or the first triangle, I'm going to pull it out. I'm going to put it back here in a second. So I'm taking this triangle out, and I'm going to rotate it around, okay, so that it matches up that corner right there. So if you look at it, it looks pretty similar. I got to make it a little bit bigger here. And I'll rearrange it, and look at this. Those 2 triangles are the exact same shape, but different sizes, and we call that similar triangle. So I'm going to put it back now. All right. So the 2 triangles, inside are similar, which means same shape, different size. Now, if they are similar and you saw me overlap them, that means that if they match up, if they line up, then this angle and this angle are going to be equal. That would mean that this angle sorry about that. So that would mean that these 2 angles then are also equal because these triangles are similar. So the angles, even though it's a different size, you saw me flip the triangle around and they lined up or they matched up. And that would mean down here then these 2 angles would be equal. So in the bow tie, we have angles that are equal to each other. So if you see a bow tie pattern, okay, and I'll emphasize the bow tie pattern here. Here's that bow tie. Then you know you have corresponding angles that are equal. So therefore, corresponding angles are equal. Okay. 2 more properties. What happens if we construct a triangle using the diameter? What happens if we use a triangle that uses the diameter as its base? So that is the diameter, passes through the center O. What you find is it doesn't matter how you draw that triangle, the angle that meets up here is always 90 degrees. So at point A. So, if a triangle uses the diameter of a circle as its base, angle A, I'll put from diagram, is always 90 degrees. So it's always 90 degrees. All right. And the last or third property is what I call the Star Trek symbol. The Star Trek symbol. Okay, from the Next Generation, kind of that badge they wear? Communicator? No one? Come on, someone's got to be a geek and watch Star Trek. Don't sit there saying you don't watch Star Trek. Everyone watches Star Trek. Okay, so what does this tell us? You'll notice that both of these shapes share a common set of points. So if I was to create a triangle here, okay, and sorry, this is the center of the circle, by the way. Okay, if I was to create a triangle out of this, we would find that the relationship of this distance to this distance creates it such that this angle is always twice as big as this angle. So if this angle is theta, this angle is 2 theta. So it's twice as much. So the central angle and I'll put angle at center of circle, or angle inside the radii, is always twice as big as the angle between the chords. Oops, I'll try right now, in between the chords. All right, so I'll just clean that up a little bit in there. So if this is theta, this is going to be 2 theta, twice as big. So there we go. There are 3 properties. So I have a couple of examples to go through with you, and then I'll let you try a couple on your own, and we'll talk about that when we meet. So find the missing angles. Left way too much space here. If I tell you this angle is 60 degrees, what angle will you then know? Then I can hear everyone screaming, I know this angle, and it's going to be equal to 60 degrees. All right, so that's the bow tie. So these 2 are examples of our bow tie. What happens if I tell you that this angle is 40 degrees? Again, I can hear everyone with their hands up. You don't need to put your hands up. This is a video. I can't see you. Okay? But this angle here then is going to be 40 degrees. Okay? These are your corresponding angles. Okay? So these are the 2 examples of our bow tie. All right? What are the examples here? We start mixing them up a little bit. This has got to be indicated on the diagram. If it doesn't, you can ask. What do we know about that angle there, or about that triangle there? Well, you can tell me that at point A, the angle is 90 degrees. Okay. Now the second one, so this is the 90 degree, so this is the diameter triangle. Diameter triangle. This one down here, I have to give you one of the angles. So what happens if I tell you that this is 50 degrees? What would this angle be? Okay, we know that it's twice as big. So therefore, it's going to be 100 degrees. All right. I have 2 last examples here. Again, it's O, and then the other one, I'm going to give you, this is, let's say, 120 degrees. So going up to the first one again, as soon as you see that the diameter is part of the circle, you know that this is 90 degrees. Okay? Always 90 degrees. And finally, this one, I know that this is twice as big, so that would mean that this one is half as big. So therefore, 120 divided by 2 gives me 60 degrees. All right. And that concludes Unit 1. If you have any questions, make sure you ask, and you'll be practicing a bunch of these questions to make sure you have understanding of our 3 final angle properties. Good luck.